This case study is about Danny's diner. So Danny seriously loves Japanese food. So at the beginning of 2021, he decided to open up a restaurant to sell his three favorite foods, which are sushi, curry, and ramen. So the problem that Danny faces is that with all the data that he collected ever since he started his restaurant, he has no idea how to use it. So some of the questions that Danny would love for us to answer for him include his customers' visiting patterns, their expenditures, and their favorite menu items. And this will be important to Danny because it will allow him to understand his customers and to also give them a personalized experience that will keep them coming back for more. So the insights that we'll give Danny from analyzing the data he'll provide for us will also help him to decide whether or not he wants to expand his existing customer loyalty program. So at the end of this analysis, you're going to generate some basic data sets for Danny and his team to use without necessarily using SQL, which they can just quickly skim over and get the insights they need. So this is the data that Danny has provided for us. We have three data sets. We have the sales, the members, and the menu. So the sales contains the sale transactions, whatever the customer bought and when they bought it. The members table is the one that has the customers who are part of Danny's loyalty program, and then the menu table is the one that has the names of the items that Danny sells in his restaurant. So we're going to begin. For this project, you're going to be using Microsoft SQL Server. You can use any SQL dialect that you have, but this is what I chose for this particular project. So the first thing I'm going to do is actually create the database and the tables that are going to hold the data from the data sets that Danny has provided for us. So I'm assuming that if you already reached a point where you're doing a project, you at least know how to create a database, create tables, and insert data into them. So I've provided below a template that has the queries for creating the database, the tables, and inserting the data. So you can download it from the link that will be in the description below. And then it also has the list of the questions that you're going to be answering in our case study. So you're going to download this template, you open it up in your SQL Server or whichever dialect you're using, and then after you have run all of them, you just come here on this left side and then you click on databases, and then you'll see your database here. Mine is called Danny's Diner, so you'll see it here on the left. When you expand it and you go to tables section, you'll be able to see your three tables. There's members, menu, and sales tables. So after you're done running all of this, you can come back and you can start answering this question. So this case study, we were provided with a total of 12 questions. So we're going to answer these questions using this data that Danny has provided for us. So just a quick overview of the tables. The sales table, it has the customer ID, the order date, and the product ID. So for you to be able to follow along properly, you may want to write this down. The menu table, it has the product ID, the product name, and the price. And then the members table just has the customer ID and when they joined Danny's loyalty program. So once you're done running this, you can come back and start with the first question. So question one is the total amount that each customer spent at the restaurant. So for this, we are going to need the customer ID as well as the price column. So the customer ID is we'll take it from the sales column, and then the amount that each customer spent, which is the price, will be from the menus table. So we're going to do a select, and then before you select our columns, I'm going to indicate which tables they're going to come from. Sales is, since they are coming from different tables, I'm going to use their aliases to refer to the columns that I want from each table. So I'll refer to the tables first and then choose the column. So we're going to select the customer ID from the sales, and then we're going to join in the menu table with the alias M. So we are going to select s dot customer ID. So you can see just picks it up automatically. And then from the menu table, you're going to pick the price. So we are going to select all this, but then we want the total amount that each customer spent. So for this, we're going to use the sum function. And then alias it as total spent. from the sales table, we join in the menu table. So this join is basically like an inner join. It will give us the matching columns from both tables, the matching records, I mean. And then the column that is going to join them is actually the product ID, which is in both tables. S.product ID is equals to M.product ID. And then, of course, we're going to group by the column that you did not aggregate. So group by S.customer ID. You put your semicolon. So when you execute this, you'll see customer A spent $76, B 74, and C 36. So that was actually quite simple. So question 2 is how many days has each customer visited the restaurant? So you may find that a customer has maybe visited the restaurant like maybe 2 or 3 times in the same day, but we want to see how many unique days has the customer visited the restaurant regardless of how many times in one day they have bought items at the restaurant. So for this, we're going to use the order date. So you're going to select the customer because you want to see each customer, and then all of this is going to come from the sales table. So we're going to select S.customer ID and then how many days. So we're going to use the count function, and then we're going to count the unique number of days, because if a customer has visited the restaurant several times in a day, those will be different orders and they'll be represented differently in the table. So we want the unique days. So it will be, we're going to alias it as days visited from the sales table. Then we're going to group by customer ID. So when you run this, customer A has visited for 4 days, B 6, and C 2 days. So that was also quite easy. Then number 3, what was the first item from the menu that was purchased by each customer? So for this, we're going to break down this query. The first thing that I did was actually calculate the first purchase date for each customer. So we're going to first find out the first purchase date, and then we'll later on use the results of that to find which item was actually purchased on that day. So we're going to select the columns. All of these are going to be, the purchases are from the sales table, so it's aliased as S. So we're going to select the customer ID, and then we're also going to select the order date. But then this order date, since we want the first item that was purchased, we are looking at the first purchase date for each customer. So that means we're going to use the minimum function because it will give us the earliest date. So I'm going to do minimum of the order date, and then we're going to call it as first purchase date as the first purchase date, and then from the sales table, and then we are going to group it by customer ID. Yeah, so this, when you run this, let's just run this and see. We're going to get the first purchase date of each customer, which was the 1st of January. So that is accurate based on what you know about Danny's restaurant. So the result of this, we're going to now use these results that we've gotten to find the first item that was purchased and the names of the items that are actually in the menu table. So we're going to join the menu table to this result set. So I'm going to convert this into a CTE. A CTE is basically like a temporary table. So we're going to do with, I'm going to call it customer underscore first underscore purchase, with customer first purchase as the results of this query that we have just run. So let's format it a bit. With the results of this, now we are going to write our main query that will select the item that was first purchased by the customer. So we're going to select again from the results that we got here. We're going to select some columns from the customer first purchase. The alias will be CFP. So we're going to select the customer ID. We're also going to select the first purchase date. Yeah, and then now we're going to select the item that we want, which is the product name. And this will come from the menus table. So we're going to select all of these from our result set or our temporary table called the customer first purchase, and then we're going to join in the sales table and we're going to join in the sales table on the customer ID as well as the order date. So this will link the customer's first purchase with the corresponding sales record. So we're going to join in on the common column here is the customer ID, and then you're also going to join in the first purchase date to make sure it is equal to the order date that is in the sales table. And then now you're going to join in the menu table so that it can give us the item name. So it will be on m dot the product ID is equals to s dot the product ID. So this is going to retrieve for us the product name that corresponds to each sales record. So to be able to run this query, we'll actually need to, since this query is so long, I'll actually just come up here on this minus sign and just collapse it so that it's easier to run. You select all of it and execute. So customer A, on their first purchase, they bought sushi and curry. Customer B bought curry. Customer C bought ramen and ramen. So if you remember, when we first ran our first query, the first purchase date for all of them was on 1st of January. So this shows us that it is accurate. These are the items that they bought on this as their first items when they visited Danny's restaurant. So the next question is the most purchased item on the menu and how many times was it purchased by all customers. So for this one, we are going to select the product name and then we are going to use the count function to calculate the total number of times that the item was purchased. So we are going to select all of this from the sales table, and then you're going to join in the menu table. Remember, the menu table is the one which has the product names. Yeah, so you're going to select the product name actually. You're going to select the product name and then we do a count of all the records and then give it an alias as total purchased. This will give us the number of times that each item was purchased by all customers. And then from the sales table, we'll join in the menu table with the column of the product ID. So s.product ID is equals to m.product ID. And then you're going to group by the product name. And then you're going to order by the total purchased descending. So you're using the descending keyword because we're looking for the most purchased item. So that means we need to give an output of only one item. So if you're using another SQL dialect, like maybe MySQL Workbench or maybe SQLite or something, you're going to use limit one. But because you're using Microsoft SQL Server, the syntax is a bit different. So you'll need to use top one. So top one in Microsoft SQL Server is the same as limit one. So it will come just after select. So when you run this, it shows us the most purchased item was actually ramen. So if we do maybe like a top three, it will give us a slightly different result set. So you can see ramen was bought 8 times, curry 4 times, and sushi 3 times. So the most purchased item was ramen, which was bought 8 times, and that's why we ordered by the total purchased descending, so that the one that was purchased the most can come on top. So for now, we'll get it back to top one. because we want the most purchased item. Number 5 is which item was the most popular for each customer. So we are actually going to break down this question. The first thing we'll do is actually count how many times each item was purchased, and then now we'll find which item was purchased the most. That will be the item that is most popular for each customer. So we're going to write this query, and you're going to select some columns from the first table is the sales with the alias S, and then you're going to join in the menu table which has the item names that we want. So we need to know who the customer was, and then the product name from the menu table. And then we're going to use the count function to count how many times each item was purchased. So this will be labeled as purchase underscore count. The alias is purchase underscore count, and then now here we are going to be using the row number function. So this function is used to assign a rank to each combination that will be there for the customer and the product, and it will be ordered by the purchase count in descending order within each customer group. That will be by using the partition by keyword. So the most popular item for each customer will have a rank of 1. So let me just show you the syntax for that. So we'll do row underscore number. Make sure you put the parentheses and then over. So the over keyword, it specifies the group of rows over which this window function will operate. So it defines the partitioning and the ordering of the rows. So if you've not used the over function before, you can go and do a bit more research about it, and then we're going to use the partition by keyword. So with this, we're going to partition by the customer ID. So the partition by, it divides the rows into partitions based on the values in the customer ID column. So each partition will have its own like sequential numbering starting from 1 for each partition. So the sequential numbering basically means you'll start from 1, 2, 3, 4, 5, 6, like that in that order. So you're going to partition by the customer ID, and then you're going to order by the count descending. And then you put another parenthesis to close up the over function, and then you'll give this the alias of rank. So the order by descending, we're going to order by the count descending. So this basically means that the highest count will be on top and then the lowest will be at the bottom. So we're going to select all of this from the sales table, and then we're going to join in the menu table on the product ID. That is the common column for both tables. So product ID is equals to m dot product ID, and then now we're going to group by all the columns that have not been aggregated. So that is the customer ID and then the product name as well. So when you run this, it should give us the number of times each product was purchased and the rank for each customer. So for example, customer A, it lists for us every product customer A has bought, how many times it was bought, and the rank according to all the items customer A purchased. So for example, customer A bought ramen, curry, and sushi. Ramen was bought 3 times, sushi 2 times, curry 2 times, and sushi once. So the rank of each of those items according to how many times was bought is ramen, since it was bought the most, has a rank of 1, and then curry has a rank of 2, and sushi has a rank of 3. So what we're trying to do is actually get the item that was the most popular for each customer. So for example, we want our final query to output for us customer A ramen, and then customer B will be sushi, and then customer C will be ramen. So that is what we want our final query to output. So we are going to use this first query that we've written, and we are going to write another query that will use the results of this query to give us that result that you are looking for. So again, I'm going to convert this into a CTE, or rather a temporary table, and I'm going to call it customer popularity. So up here I'm going to do with, you can give it any other name you want as long as it's descriptive, customer popularity. So with customer popularity as that, and then you indent it with customer popularity as that. So now you're going to write our main query. You're going to select all of this from customer popularity. So you can give it an alias, let's call it CP. So it will be cp dot customer id, since you are querying from that first query that you've written, and then cp dot product name. See, when you do that, they just appear, and it is faster. From cp dot purchase count, and then you're going to write a condition. So we only want to output the most purchased product for each customer. So we only want the product names where the rank is 1. So where the rank is 2 and 3, you're not interested in that. Only products which have a rank of 1. So we're going to write here a condition using where rank is equal to 1. Put a semicolon, and then again, since this query is very long, you're going to collapse it using the minus sign. You select all of it, and then you're going to execute. So customer A is ramen, customer B sushi, customer C ramen. So if you look at the results of this query, you can see that for customer B, sushi is the one that was ranked as the first product. But if you remember the previous question number 4, the product that was bought most by the customers was actually ramen. So this had me thinking. So I went back to the sales table for the customers to look at the records of customer B and why his ramen was not ranked as the first product in his results. So when you check customer B, you can see each of the products, he bought them twice. He bought curry twice, sushi twice, and ramen twice. So this means that if you're ranking the products, that means all 3 products should appear for customer B. But that's not what has happened. It's only sushi that is appearing for customer B. So this made me do a bit more research, and I realized that the row number function, it actually just gives like sequential numbering for each row. So it will give you number 1, 2, 3, but in case there's a tie, it will not give all those values the same number. So after I did a bit of research, I came across the dense rank function. So the dense rank function, it allows ties, and it assigns the same rank to rows with equal values. So based on the results you're getting here, it means you need to use the dense rank function instead of the row number function. So if you use the dense rank function, sushi, ramen, and curry, they'll both be ranked number 1, and so they will appear on the result set. So we'll just come up here and we'll replace row number with dense rank. If you want, you can read more about it. So after I do that, and I come and run this query again, you should see all 3 products appearing for customer B. Yeah, so this is the output that you are seeking. So by doing this question, it actually makes you realize that you need to be paying a lot more attention when you're doing your analysis. Yeah, and also just make sure you always cross-check the queries that you get, because SQL won't necessarily give you like an error, except maybe if it's a syntax error. But if you query the wrong thing, it will give you output, but it's probably not what you wanted. And then number 6 is which item was purchased first by the customer after they became a member. So for this one, again, you're going to split this into 2 parts. So the first thing we're going to do is actually look at the first purchase that was made by the customer after they became a member. So we need to find out what purchase date it was and all those details, and then after that, the results of that now we are now going to use to find the item that was purchased. So we're going to use the sales table, the members table as well, because the members table, you have to check whether or not they were a member when they bought those items. So we're going to select certain columns from cells S, and then you're going to join in the members table, because because we want to find matching records. So members will be MB. So for this, we're going to select S dot customer ID, and then you're also going to find the order date. So this was the first purchase after they became a member. So after they became a member, which we want to find the very first item they bought. So we're going to be using the minimum function. We're going to find the minimum order date for whatever it is that they bought. So it will be S dot the order date, but then we want the minimum, which will be the very first date of purchase after they became members, and then we're going to call this the first purchase date. As the first purchase date, all of it from sales, we join in the members table on all of them have the customer ID is equals to mb.customer ID. So if you're having trouble like finding out which columns are in which, just make sure you wrote them down like I had told you earlier, the columns for each table, so you're able to easily follow along. And then after that, you're going to check that the order date that is in the sales table is actually greater than or equal to the join date that is in the members table. So this means that this purchase by this customer was actually made on the day they became members or any other day after they became members. So we're going to write a condition where s.order date is actually greater than or equal to mb.join date. Then we're going to group by customer ID. So we'll run that query first so that you can see when they made their first purchase date, their first purchase. So customer A made it on 7th of January, customer B on 11th of January. So this means that customer C was not yet a member, or rather is not a member of Danny's loyalty program. So using this result, we are now going to find the item that was bought on those particular dates. So again, we are going to convert this into a temporary table that we are going to query from. So I'm going to call this first purchase after membership. Yeah, so with first purchase after membership, it will be that query that you've just run. And then now we'll write the main query to find for us the item that was bought on those dates. So for this, we're going to select from this new temporary table we have created. So it will be called fpam as the alias, and then we're going to join in the sales table on the customer IDs. And you're also going to join in the first purchase date and the order date so that we're able to make sure that whatever is in the members table also corresponds to whatever is in the sales table. So s dot the customer ID is equals to the fpam dot the customer ID, and then use the AND operator. Make sure that fpam dot the first purchase date is the same as s dot the order date that is in the sales table. And then again, you're going to join in the menu table so that you can find the item name. So join the menu M on the product ID that is in the sales table. Should be the same as the product ID that is in the menu table. Put the semicolon. We're going to select the customer ID and also select the product name from the menus table. So when you collapse this, you select and you run, it will show us that customer A, they bought curry, customer B, they bought sushi as their first purchase after they became members. Number 7 is quite similar, which is the purchase just before the customer became a member. The only thing we're going to change here is actually checking that the order date from the sales table is actually less than the join date that is in the members table. So for this, we are again working with only customer A and B because customer C is not a member. So we are going to write a query that will select for us the customer ID and then the order date. So this will be the last purchase date before they became members. So we are going to use the max function because it will give us the most recent date, but then we'll specify the condition that checks that that purchase was actually less than the join date for them when they became members. So we're going to select this from the sales table S, and then we're going to also join in the members table just to make sure that they are members. Yeah, and then you're going to join it on the customer ID. So we're going to select customer ID from the sales table, and then you also select the order date. But this time we're going to be using the max function because we want the most recent date. So this will be labeled last underscore purchase underscore date. And then we join in the members table on the customer ID. So it will be s dot customer ID is equals to, members should actually be MB, not M. M is for menu. So it will be MB dot customer ID. Then we write our conditions. So where the join date, no, where the order date in the sales column is actually less than the join date that is in the members column. And then you group all this by the customer ID. So when you run this, it should give us the purchase date for those customers who are members. So the last purchase date for customer A was 1st of January, customer B was on 4th of January. So this again, you're going to use these results now to find which item was purchased. So again, I'll convert this into a CTE. So this will be called last underscore purchase underscore after membership. I mean last purchase before membership. With last purchase before membership as this query that we've just calculated that shows us the dates when they last made any purchase. So we're going to be using the results of this to select the item that was bought. So we're going to select from the last purchase before membership, which will be LPBM, and then we're going to join in the sales table to make sure the customer IDs match, and then also the purchase dates and the order date, we have to make sure they match in both our tables. And then we join in the menu table to give us the item that was bought. So we're going to join the sales table, and then we're also going to join the menu table. So from here, we're going to select the customer ID from our temporary table, LPBM dot the customer ID. Then you're also going to select the product name. From our temporary table, we join in the sales table on the customer ID. So it will be dot customer ID is equals to s dot customer ID. And then we also need to check that the purchase date and the order dates in both tables match. So it will be LPBM dot the last purchase date is equals to s dot the order date. And then now we join in the menu table to be able to find out which item was last bought. So on we check using the product ID, it is common on both tables. So m.product ID. So again, this query is so long, so you're going to collapse it up here. You select all of it and then you run it. So customer A, the last item they bought was sushi and curry, then customer B was just sushi. And then number 8 is the total items and the amount spent for each member before they became a member. So again, the results of this query should only give you customer A and B because customer C is not a member. You're going to select some items from the sales table, and then we want to find the total item, so you're going to join in the menu table because it has the items that are being sold in Danny's restaurant, and then we're going to join in the members just to check that the customers are actually found in the members table. Yeah, so from this you're going to select the customer ID from the sales table, and then now we're going to count the total items. And then also we want to find the total amount that was spent, so we're going to use the sum. The price column is found in the menu table, so it will be m.price, and then we'll call this as total underscore spent. Yeah, and then we select all of this from the sales table, we join in the menu table on the product ID. This will give us the items information. So dot product ID is equals to m dot product ID, and then we join in the members table to make sure that the customer who appears in the sales table also appears in the members table. So you join in the members on the customer ID that is found in both tables. And then now we write a condition to check because we want to find the total items and amount spent before they became members. So the order date that is in the sales table should actually be less than the join date. Order date which is less than, because we want to find the totals of before they became members, and then of course you're going to group by the only column that was not aggregated, which is the customer ID. So we run this. Customer A bought a total of 2 items, and then customer B bought a total of 3 items. Yeah, customer A spent $25, customer B spent $40. Question 9, it says if each $1 spent equates to 10 points and sushi has a 2 times points multiplier, how many points will each customer have? So this means that there are 3 items. There's sushi, there's curry, and there's ramen. So if you spend on curry and ramen, you only get 10 points. But if you buy sushi, you get 20 points. So we are going to write a query that will calculate those points for us so that we can know how many points each customer has. So we're going now to select whatever column we select. We're going to select it from the sales table, and then we also need the menu table because it has the product names and their IDs and prices and all that. So we're going to join in the menu table as M on the product IDs. So here we're going to select the customer ID from the sales table, and then now we're going to write like a condition that will help us calculate the points. So I'm going to use here the sum function, and then you just indent here. So we're going to use a case-when statement. A case-when statement is basically like an if-else statement. So if a certain condition is true, then this should happen. If it's not, this other thing should happen. So we're going to do a case, and then so when m.product name m.product underscore name, want to check for the products that the customers have bought. So if the product name is sushi, then the price will be multiplied by 20 points because sushi has a 2 times multiplier. So m.price multiplied by 20. Else the price will be multiplied by 10 for any product that is not sushi. So you write end close, and then you are going to alias this as the total points. So this is the condition that will help us calculate the total points, and then you're going to do all this from the sales table we join in the menu table on the product ID. So on s.product_id is equals to m.product_id. This will help us to be able to get the product name and for our condition to check whether it's sushi, curry, or ramen. And then we're going to group by the customer ID. So when you run that, we'll see how many points each customer has. So customer A has 860, B 940, and C 360. Yeah, it makes sense that customer C has the lowest points because they only bought ramen, they never bought sushi. So there's no point where they get the 2 times multiplier for sushi. So number 10 says that in the first week after a customer joins the program, including their join date, they earn twice the points on all items and not just sushi. How many points do customer A and B have at the end of January? So this question basically means that after you join Danny's program, during the entirety of that first week, you'll get twice the points for any item that you buy. But then after that first week, now you'll go back to the regular points, which is just twice the points for sushi alone. So we are going to select some columns and then we'll write a condition that checks that for us and assigns you the points accordingly. So we'll start by doing a select, and then we're going to select from the sales, which is S, and then you're going to join in the menu table so that you can check whether the item is sushi, yeah, and so on. And then you're also going to join in the members table to check if the person was actually a member. So we'll select the customer ID from the sales table, and then now we're going to write the condition that calculates your total points according to your order date. So we're going to use the sum function because it's going to add for us all those points together depending on the condition that you're going to specify. So I'll do a case, and then so we'll write the when, and then now it will be the order date s.order date. You'll check if it is within that first week, so it is between the join date that is in the members table and then 7 days after that. So we're going to use a function called date add. So this will have an argument. For the first argument will be day because we're trying to count the number of days after you joined, and then we add by how many days, that will be 7. And then after that we specify which column is that we want to check with. It's the join date column that is in the members table. Yeah, so if this condition is true, then the price that will be from the menu table has to be multiplied by 20. Any item that you buy, the price will be multiplied by 20. If this condition is not true, it's going to check this other condition where it checks if your product underscore name is equals to sushi. So this second condition is for someone who's already past the first week. Now you're no longer in the first week after joining. You're now like just a regular customer. It will be you check if the product name is sushi, then the price will be multiplied by 20. Multiplied by 20 points, but now the others will get 10 points. And then if neither of these two conditions is true for you, the price of each product you buy will be multiplied by 10 points. So yeah, and then you close the bracket, so the sum function will add all this depending on which condition is true. So we'll end as total underscore points. Yeah, then we're going to be selecting all this from the sales table. You join in the menu table on the product ID. Is equals to m.product_id. And then we are going to join in the members table based on the customer ID. So we're going to do a left join of the members table. So we're going to do a left join because you want all the records that are in the sales table and the matching records from the members table. So typically when you do a left join, if there are records that do not match from the second table, that means they should be replaced with null. But since you have specified a condition of what values they should get, they will not be identified as null, but instead depending on which condition is true. So You're going to join members on the customer ID is equals to MB. Sorry, this is members MB dot customer ID. Yeah, and then after that, you're also going to specify another condition that checks that the customer ID that is in the sales table is also the same one that is in the members table. So you're going to write a where clause, so s dot customer underscore ID. So the question is very specific in that it says how many points do customer A and B have. So we could do where s dot customer ID in A, comma B, or we could do where s dot customer ID is equals to MB dot customer ID, because anyway we are checking that the customers are members. So I'm just going to do according to the question, but if you want to be able to apply it later on, you have to make sure that whatever is in the sales table is also in the customers table. And then another condition will be, and the order date is less than or equal to the order date has to be within the month of January. So we'll do 2021-01-31. So I'm using this date format because it is the default one for SQL. And then now you're going to group by customer ID underscore ID, then you put the semicolon. Oh, so these red lines are because this end should actually be within the bracket. Yeah, like that. So now you're going to run this. So when you run this, customer A has 1370, customer B has 940. So you have number 11, which is a bonus question that was in that case study. And it's about us creating the table that has been provided using the available data to get that same output. So this is the table that Danny has provided. So he needs us to write a query that will give him this exact output, which maybe he'll be running every week or every month, depending on his preference. So then it requires us to create basic data tables that his team can use to quickly derive insights without needing to write SQL. So using this table that's here, we need to write a query that will generate this exact table. Yeah, so we'll come up here, and the first columns, the columns that we need to generate are the customer ID, order date, product name, price, and member. So this member table, this member column is actually derived. So we are going to write a condition that will check whether the customer is a member or not during the time of the purchase. So we're going to be needing the sales and the menu table, and then also the member table just to check. So we come up here, and the first thing we'll do is write a select, then the tables that we query from sales S, and then we're going to join in the menu table M. Yeah, so we'll add the other ones as we go on. So for the sales table, we'll select the customer ID and also the order date. And then we're going to also select the product name and the price from the menu table. So M dot product name and then M dot price. Yeah, and then now we are going to create our derived table, which is the members table. So we'll write a condition for this. So we're going to write a case-when statement that checks whether the order date is greater than or equal to the join date. So if that is true, it means the customer was a member at the time of the purchase. But if it's not true, then the customer was not a member. So when s dot order date is greater than or equal to, now the members, which will be MB dot join underscore date, then we'll give this customer a value of y. It means they were a customer by the time they made that purchase. Else we're going to give them an n, which means they were not a member. So we're going to end as member. So this is now the other column that we have derived. We'll select all this from the sales table. We'll join in the menu table on the product ID, because it is the common column for both tables. So on s dot product ID is equals to m.product ID. And then you're also going to join in the members table, but this time it will be a left join. This is because we want all the records that are in the sales table, but only the matching records that are in the members table. So when you do a left join, you know the records that do not match, they usually get null values. But now, since you have specified this condition here in this case-when section, so now it will just get an n instead of a null. So we'll join in members using the alias MB on the customer ID. That is the column that they share with the sales table, is equals to mb.customer ID. And then now we are going to order by the customer ID and also by the order date. Yeah, so when you run this, it will give us that exact table that you saw. So when you run this is the output. So you have ordered by the customer ID, so that customer A comes first, then B, then C, then by the order date, from the latest to the earliest date. So if we compare this, so if we compare this output, the output that is in this table, you'll know that it is exactly the same. Yeah, so this is the query that will give you this exact output. So now we'll go to our final question in our case study. So this is about ranking all the things. So when you come back here to my website, you'll find the link in the description below. It says Danny requires further information about the ranking of products. He purposely does not hit the ranking of non-member purchases, so he expects null ranking values for customers who are not yet part of his loyalty program. So for this, basically what we'll be doing in this question is, for the results that we got in question 11, now we need to rank those customers based on those exact results. So we are going to again create this table exactly the way it is, but only rank the member purchases. So we are going to rank only those members who, the purchases that were made after those customers became members of Danny's loyalty program. So we'll select the exact same columns as previously, and then now add the ranking column, which is a derived column. So we'll come here, and the first thing we're going to do is select the column. So we'll do a select we select from the sales S, and then we'll again join in the members and the menus table. So the members table is for checking that the customers were members or not at the time of the purchase, and then the menu table is the one that has the product name and the prices. So we're going to do a left join again of the members table, because we want to get the matching records that are in the members table, and then you're going to also join in the menu table. So we are going to select s.customer ID, just like we did previously, s.order date, and then m.product name, and then m.product price, m.price, and then now it's a case-when statement, so we'll do case and then when. Now for this, we're going to check if the order date is less than the join date that is in the members table. If it's less than the join date that is in the members table, then the customer was not a member at the time that they made the purchase. And then you write again a second one if the order date is greater than or equal to the join date, it means they were members. Then you assign a Y. So this will create for us the members table, and then if it does not meet, a customer does not meet any of these conditions, then they were not a member. So N and as member. So this will create the members column, and then now we'll select all these columns from the sales table. We'll do a left join of the members table on the common column is the customer ID, mb.customer ID, and then we'll join in the menu table so that you can get the product name and the price. So it will be on s.product ID, is equals to m dot product ID. So if we run this again, you'll basically get the same output that you got for number 11. So when you run this, yeah, we get this exact same output. So this, we are going now to query. We are going now to use these results to rank all the customers based on those who are only members. Those who are non-members, they will get nulls for their values. So I'm going to convert this into a CTE, and I'll call it customers data. So we'll do with customers underscore data as that, and then you're just going to indent it so that it looks neat. With customers data as that. So now for our main query, we are going to select all the columns, and then we'll write a condition that checks if you are a member or not. If you are not a member, your record gets a null value, because Danny only wants us to rank those records which were where the customers were members at the time of their purchase. So we'll write a case when statement. So we'll do case, and then when member is equals to, if the customer was not a member of the time of the purchase, then their record gets a null. Else gets a null. Else they get ranked. So we'll use the rank function. Then we do over. So we'll do partition. We're going to partition them by the customer ID. Partition by customer ID, as well as whether or not they're a member. And then also we're going to order by the order date, order underscore date. Then you're going to close this. Then you're going to end this as ranking. That's the name of the new derived column. You're going to end it as ranking. And then you're going to select all this from customers data, which is the CTE that you just created. And then now we are going to order the results by the customer ID as well as the order date. Yeah, then you put a semicolon. You come up here, you collapse this, and you run it. It should give us the same results that are there. So these are the results that you get. And when you compare this, especially this ranking, when you come back here to this table, you can see it's exactly the same. There's null, then there's 1, 2, 3, 3, null, all that, then 1, 2, 3. And it's the same exact results that you get. So if you need access to these tables, you can check my description below. My website will be linked. Yeah, so that is the end of this video. If there is any of the functions which you probably didn't understand, you can just Google those and you'll be able to learn more and understand them better. Yeah, so that marks the end of this project. I'll see you guys in the next video.